Section 3.6, Zeros of Polynomial Functions. In this section, you will use factor theorem to solve a polynomial equation. You will also find zeros of polynomial function, and also you will solve real-world applications of polynomial equations. Now let's start with the factor theorem and solving polynomial equations. If we can factor a polynomial, then we can find its zeros pretty easily. This works backwards as well using synthetic division and the next handy theorem. Okay, the factor theorem. According to the factor theorem, k is 0 of f of x if and only if x minus k is a factor of f of x. So think about, let's say, this graph here, a cubic, an example. These are the zeros. So we can say that we have 3 zeros here. What do you mean by this? X minus k is a factor of f of x, meaning that divides f of x with no remainder. Okay. Alright, let's start with example 1. Show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. Find the remaining factors, then use those factors to determine the zeros of the polynomial. So, given x cubed minus 6x squared minus x plus 30 divided by x plus 2. So by using synthetic division, remember this, x plus 2 we use negative 2, and then the coefficients, x cubed is 1, x squared is negative 6, x is negative 1, and a constant 30. So what we do here is bring down 1 times negative 2 is negative 2, and then we always add this. Negative 6 plus negative 2 is negative 8, and then multiply. Negative 8 times negative 2 is positive 16, add, multiply, negative 30, and this is 0. So remember, this is a remainder, constant, x and x squared. So meaning when we divide x cubed minus 6x squared minus x plus 30 by x plus 2, that is equal to x squared minus 8x plus 15. And x squared minus 8x plus 15 is factorable, so we can factor this. X squared factors of x squared, x and x, and then this is positive 15. Find two numbers when you multiply is positive 15 and when you add is negative 8. What are those two numbers? Yes, that's correct. Negative 3 and negative 5. Negative 3 times negative 5 is positive 15. Negative 3 plus negative 5 is negative 8. So here we can say that zeros are from x plus 2, that's negative 2, x minus 3, that is 3, x minus 5, that is 5. So we know that x cubed minus 6x squared minus x plus 30 is equal to, sorry, I don't have space. The factors are x plus 2, x minus 3, and x minus 5. And these are the zeros. So if you graph this, just like our example here, those are the zeros, the points on the x-axis. These are the zeros, -2, 3, and 5. So -2, 1, 2, 3, and 5. So these are the zeros. Okay. Finding zeros of polynomial function, the main way that we are going to use the factor theorem is to find the zeros of polynomial functions. Let's get practice doing that on our next example. Example 2. Use factor theorem to find the zeros of f of x equal to x cubed plus 4x squared minus 4x minus 16, given that x minus 2 is a factor. So we can say that x cubed plus 4x squared minus 4x minus 16 divided by x minus 2 is equal to, we have to use synthetic division. X minus 2 is going to be opposite is positive 2. Then get the coefficients 1, 4, -4, -16. Then bring down 1. 1 times 2 is 2. And we always add this. 4 plus 2 is 6. 6 times 2 is 12. -4 plus 12 is 8. Times 2 is 16. -16 plus 16 is 0. So remember, from the last one, this is your remainder, constant x squared. So here, when we divide this, is equal to x squared plus 6x plus 8. And x squared plus 6x plus 8 is factorable. The factors are x squared, x, and x. Find two numbers when you multiply is 8 and when you add is positive 6. That's correct. Positive 2 and positive 4. 2 times 4 is positive 8. 2 plus 4 is positive 6. So we can say that x cubed plus 4x squared minus 4x minus 16. The factors of this are x minus 2, x plus 2, and x plus 4. And find the zeros. So the zeros are x minus 2, that's positive 2, x plus 2, -2, x plus 4, -4. So these are the zeros. After we get all the factors, that is by the factor theorem. Okay. Next one, example 3. Use a graph and the factor theorem to find all the zeros of f of x equal to 4x cubed minus 3x minus 1. Based on the graph, we have two zeros here. That is, if this is -2, this is -1, so this is -0.5, and this is at 1. So this point is the coordinates -0.5, 0, and this point here is 1, 0. So we know that zeros are -0.5 and 1. But we need to find all the zeros. I'd like to add, find the factors of the given this f of x equal to 4x cubed minus 3x minus 1. So now that we know the zeros, 1 and negative 0.5, so we can say that x is equal to 1 and x is equal to negative 0.5 is the same thing as negative 1/2. Then set this to 0. To do that, if we subtract 1 both sides, that's going to be x minus 1 is equal to 0. Here, if we multiply both sides by 2, so that's 2x is equal to negative 1, and then add 1 both sides, so that's 2x plus 1 is equal to 0. So, meaning the factors are x minus 1 and 2x plus 1. So we can say that 4x cubed minus 3x minus 1 is equal to x minus 1 and 2x plus 1. But we're not done yet. Look at when x is negative 0.5, look at the shape here. It's a parabola, so meaning it has a multiplicity of 2. So this should be squared. You should have a double root here at 2x at when x is equal to negative 0.5. So these are the factors of 4x cubed minus 3x minus 1. Okay. Next one, solving real-world application of polynomial equations. Polynomials play a key role in any problem that is squared like area or cubed like volume. Example 4. A new bakery offers decorated sheet cakes for children's birthday parties and other special occasions. The bakery wants the volume of a small cake to be 351 cubic inches. The cake is in the shape of a rectangular solid. They want the length of the cake to be 4 inches longer than the width of the cake and the height of the cake to be 1/3 of the width. And then what should the dimensions of the cake pan be? So what do we know here? So what do we have here? So length of the cake to be 4 inches longer than the width. So the length L is 4 inches longer than the width. So we can say that that is W plus 4. What else? Height of the cake to be 1/3 of the width. So we could say that height is 1/3 of the width. And the volume, we know that the volume is 351 cubic inches. Alright. We know that the volume is equal to length times width times the height. And we can use this, we can solve the volume in terms of the width, since we know that the length is W plus 4. This is the width, and height is 1/3 W, and we have a value of the volume, which is 351. So we can write that here, and with this we can solve for W. Let's simplify this first. So 351 is equal to, when you multiply this, W times W times W is times 1/3 is 1/3 W cubed, and then plus 1/3 times 4 is 4/3. W times W is W squared. And then what's the easier way? To get rid of this denominator, we can multiply everything by 3. 3 times 351 is 1053 is equal to w cubed plus 4w squared. And if you subtract 1053 both sides, that's going to be 0 equals w cubed plus 4w squared minus 1053. Then this, the graph of this is actually this one. This is the graphical view of that. And part of the graph, it crosses at this point. And this point is at 9, 0. So meaning this is the 0. At 0 is at 9. So meaning since our volume is in terms of the width, which is the w, so we can say that our width is equal to 9. And then now we can solve for the length, w plus 4, so 9 plus 4 is equal to 13, and our height is 1/3 of the width, so 1/3 times 9 is equal to 3. So we have 9, 13, and 3. So we can say that the length is 13 with the width of 9 and the height is 3. So that is our answer. So 9 inches is the width, 13 inches the length, and 3 inches is the height. Okay? Alright. Now let's solve some lecture questions. For the following exercises, use the factor theorem to find all the zeros of the given polynomial function. One factor is already given for each problem. So number 14, 2x cubed minus 9x squared plus 13x minus 6, and given one of the factors is x minus 1. And remember, to do this is use the ACS is by using synthetic division. So x minus 1, use positive 1. And then write down the coefficients. So 2, negative 9, 13, and negative 6. Then bring down 2, multiply 2 times 1 is 2, add negative 9 plus 2 is negative 7, times 1 is negative 7, add 6, multiply positive 6, negative 6 plus 6 is 0. And we know that this is remainder, constant x squared. So we have 2x squared minus 7x plus 6. So let me write it down. 2x cubed minus 9x squared plus 13x minus 6 is equal to, the factors are x minus 1 and 2x squared minus 7x plus 6. And then now this is factorable. Let's get the factors. X minus 1, 2x squared, so that's 2x times x. And then what are the possible factors of positive 6? That's negative 2 and negative 3. So you can check if that is correct. We want negative 7. So let's try that. Negative 3 times x is negative 3. 2 times negative 2 is negative 4. And if we add this is -7. So meaning that is the correct, those are the correct factors. So these are the factors, and then we can get now the zeros. The zeros are x minus 1, so that's 1. 2x minus 3 is 3 halves. And x minus 2, that is positive 2. Okay, next. Number 20, 4x cubed minus 7x plus 3, and given the factor is x minus 1. So let's use again synthetic division. X minus 1, so we use 1. 4x cubed minus 7x plus 3. 4x cubed is 4. Don't forget you're missing x squared here, so meaning there should be a 0 here. Then -7 and positive 3. So don't forget that. This is very important. Okay, then bring down 4. Multiply 4 times 1 is 4. Add 0 plus 4 is 4. Times 1. Add. Times 1. Add 0. So this is remainder, constant x and x squared. So we can say that 4x cubed minus 7x plus 3 is equal to, the factors are x minus 1 and x squared, 4x squared plus 4x minus 3. And this is still factorable. For x squared, factors are 2x and 2x, and then -3. Let's try -1 and positive 3. So we check. -1 times 2 is -2. 2 times 3 is 6. 6 minus 2 is positive 4. That is correct. So these two are the correct factors. So the zeros are x minus 1 is positive 1. 2x minus 1 is opposite of that. -1 is positive 1 over, in front of x is 2, so that is 1/2. So you do the same thing here. 2x plus 3, so -3 over 2. So these are the zeros. Okay. All right. And the last problem. Number 63, use your graphing calculator to graph the polynomial function and use the graph to find all of the zeros. So this is the given. F of x equal to 8x cubed minus 6x squared minus 23x plus 6. You can use a TI-84 or TI graphing calculator, or the easiest is by using Desmos. Okay, so all you have to do is just enter this 8x cubed minus 6x squared minus 23x plus 6. And you should have something like this. And we need to find the zeros. These are the zeros. And this is actually exactly -1.5. This one is 0.25 when you trace it, or using Desmos you just click on the point on the x-axis and you will see the exact x value, and this is 2. So these are the zeros. Okay, and that's it. Thank you.